This videotape deals with addition, subtraction, and multiplication of polynomials. We have already discussed to a certain degree doing arithmetic on algebraic expressions. In this videotape, we will go into a bit more detail. Most of the algebraic expressions we have been working with so far are called polynomials. An algebraic expression that can be formed by using only the operations of addition, subtraction, and multiplication on constants and variables is called a polynomial. Let me give you some examples. 5x squared is a polynomial having one term. 3x to the fifth minus 2xy is a polynomial having two terms. Okay, notice how, for example, 5x squared was formed by using the operation of multiplication on constant 5 and the variable x, and then 5 times x times x. Okay, here, once again, we are using only the operations of addition, subtraction, and multiplication on constants and variables to form this polynomial. As a third example, let's look at minus 6x squared minus 8x squared y cubed plus y to the fourth, a polynomial with three terms. By the way, a one-term polynomial is often called a monomial, a two-term polynomial a binomial, and a three-term polynomial a trinomial. Okay, now let's look at 3/4 x. This is a monomial. It's one-term polynomial. Don't get confused with what looks like division. This is really the constant 3/4 times the variable x. So this is a polynomial. Okay, but 4/3x is not a polynomial. Okay, now let's look at the difference. Well, you could say, well, isn't this really 4/3 times 1/x? Well, it is, but 1/x involves division. It's a constant 1 divided by a variable x. Okay, it's okay to take 3/4 and say, well, that's just one constant. You're multiplying it by a variable. If you must consider it a problem with division, in other words, you have a variable here in the bottom, this has to be division by a variable. This is not a polynomial. We are restricted to using the operations of addition, subtraction, and multiplication on constants and variables. Okay, for this reason, 3/4 x squared minus 2/5 x plus 3 is a polynomial. But 3x minus 2/4x plus 3 is not a polynomial. This could be thought of as the constant 3/4 times x, take away the constant 2/5 times the variable x plus the constant 3, using addition, subtraction, and multiplication on constants and variables. This involves division. Okay, division by a variable. This is not a polynomial. Okay, now I want to define what we mean by the degree of a term in a polynomial and also the degree of a polynomial itself. I'm going to illustrate these ideas on this three-term polynomial over here. Okay, now there are three terms. The first term is the minus 6x squared. The second term, the minus 8x squared y cubed. The third term, y to the fourth. Okay, now each term in the polynomial has a degree. The degree is equal to the sum of the exponents of the variables in that term. Okay, the degree of a term. Okay, it's the sum of the exponents of the variables in the term. Okay, the first term has therefore degree 2. There's only one variable in that term, x, and it has the power 2, the exponent 2. The degree of the first term has degree 2. The second term here, the minus 8x squared y cubed, has two variables, x and y. We add up the exponents of the variables, 2 plus 3, so we see that the second term has degree 5. And the third term only has the variable y. Its power is 4, so the third term has degree 4. Okay, the term of highest degree here is the second term. The second term had degree 5. 5 is also known as the degree of the polynomial. That is, the degree of the polynomial is defined to be the degree of the term of highest degree. Okay, so we look at each term in the polynomial. We look at their degrees, in this case 2, 5, and 4. The largest one is 5. That is the degree of the polynomial. So this particular polynomial has degree 5. Okay. This polynomial has degree 5. Now we have already discussed addition and subtraction of polynomials, except when we did it we called it combining like terms. Let's review what we already know about that. Okay, let's say we want to add two polynomials, 5x squared plus 3xy plus y cubed, and we'd like to add to that this polynomial 7x squared minus 5xy minus 2y cubed. Okay, now what we're going to do is combine the like terms. We see we have a 5x squared and a 7x squared, giving us 12x squared. To combine like terms are terms that have the exact same variable part. Okay, this is the constant part of the term, this is the variable part. So the terms 5x squared and 7x squared are identical in their variable part. These are like terms. They both have x squared. We add the constant parts, the 5 plus 7, we get 12x squared. Now we have 3xy take away 5xy for a result of minus 2xy. And then plus y cubed take away 2y cubed. Those are like terms, giving minus y cubed. So our answer here for the sum of these two polynomials is 12x squared minus 2xy minus y cubed. Okay, by the way, you could also add these polynomials in a vertical fashion rather than horizontally. To do that, you would add them up vertically, trying to put the like terms underneath each other. So, for example, we'd have 7x squared minus 5xy minus 2y cubed. Some people find it a little easier to do it this way. The like terms are right underneath each other, and you have 5x squared plus 7x squared giving you 12x squared, then the minus 2xy, and the minus y cubed just like before. You should be able to do it either horizontally or vertically. Okay, now let's try a subtraction example. Subtract x cubed minus 2y squared from 3x cubed minus 8y squared. Okay, this means subtract this from this. So we would start with the 3x cubed minus the 8y squared, and we're going to subtract from that x cubed minus 2y squared. Okay, now, two ways of looking at this. One way, when you're going to subtract, of course, you know you can add the opposite. So what we can do is simply change the sign of every term in the parentheses and then add. Or you can think of this as really minus 1 to be distributed through the second parentheses. Either way, you get 3x cubed minus 8y squared. Now, either you say this is plus x cubed and you're going to reverse it and make it minus x cubed, and minus 2y squared, you reverse it and make it plus 2y squared, and then you add, or you distribute the minus 1. Minus 1 times plus x cubed gives you minus x cubed. Minus 1 times minus 2y squared gives you plus 2y squared. Okay, so either way, you wind up changing the signs in the second parentheses and adding. Okay, now it's combining like terms all over again. You have 3x cubed, take away 1x cubed. Take away x cubed is really taking away 1x cubed. Okay, giving you 2x cubed. And minus 8y squared plus 2y squared to give you minus 6y squared. Okay, now we're going to consider the idea of multiplication. Now we'll start off simply. We're going to multiply a polynomial by a monomial. Okay, multiply a polynomial by a polynomial that has only one term. Okay, let's try that. The basic idea here is going to be distributive law. You've seen the distributive law, a times b plus c is a times b plus a times c. It can also extend to more than two terms in here. For example, a times b plus c plus d is really a times b plus a times c plus a times d. And if you had more than three terms, it would work the same way. Okay, this is how we're going to handle multiplication by one term. 3x squared times x cubed minus 4x plus 2. Okay, this is like the a times b plus c plus d. So we're going to get a times b, that is 3x squared times x cubed. Okay, now the 3x squared times the minus 4x will give us, okay, let's just write it, 3x squared times the minus 4x, and then the 3x squared times the 2. A times b plus a times c plus a times d. You can put parentheses around the first terms here. Of course, they're optional. A times b plus c plus d gives you a times b plus a times c plus a times d for a final answer of 3x to the 5th. Okay, we're going to multiply here. We have the same base, different powers. We add the powers. Minus 12 x to the 3rd, this is really x to the 1. X to the 1 times x to the 2 gives you x to the 3, plus 6x squared. 3x to the 5th minus 12x cubed plus 6x squared. Let's try a fairly simple example. We're going to multiply a binomial by a binomial. That is a two-term polynomial by a two-term polynomial. We can do that over here. So we want to multiply x squared plus 2 times x plus 3. Okay, we can think of this as a plus b times c, which of course would give you AC plus BC using the distributive law. Whereas I'm going to group these two together, x plus 3, and make this like the c. This is like a plus b times the c. Okay, accordingly we will get a times c, that is x squared times x plus 3 plus b times c, 2 times x plus 3. See if you follow that. We pretend that x plus 3, that's all c. It's going to be a plus b times c, a times c plus b times c, x squared times x plus 3 plus 2 times x plus 3. And then we're going to just use the distributive law again here and here. This is again like a times b plus c, a times b plus a times c, x squared times x plus x squared times 3, and then 2 times x plus 2 times 3, giving us x cubed plus 3x squared plus 2x plus 6 for an answer. Okay, now let's see what happened here and see if we can develop some sort of general rule for multiplying polynomials. Okay, x squared times x took the first term in this polynomial times the first term in this one. X squared times 3 took the first term here by the second here. Then 2 times x was the second times the first, and 2 times 3 is second times the second. So what we did was multiply each term in the first parentheses by each term in the second parentheses, giving us these 4 terms, which we added together to get the final result. Okay, and this is going to be our general rule for multiplying polynomials. To multiply two polynomials, multiply each term of the first by each term of the second. Multiply each term of the first polynomial by each term of the second, and then combine like terms if there are any. How about x plus 3 times x squared minus 3x plus 4? Okay, once again I'm going to do this using the distributive law several times. Okay, you could think of this as a plus b times c, if it helps. A plus b times c, which is ac plus bc. This whole thing here we're going to call c. A plus b times c, so it is a times c, x times x squared minus 3x plus 4, plus b times c, 3 times x squared minus 3x plus 4. A plus b times c, a times c plus b times c, x times x squared minus 3x plus 4 plus 3 times the same thing. Now, using the distributive law again here and here, we get x times x squared for x cubed, x times minus 3x for minus 3x squared, x times 4, 4x, and over here, 3 times x squared, 3 times minus 3x for minus 9x, and 3 times 4 for 12. Okay, notice how we have multiplied every term in the first polynomial by every term in the second. The x was multiplied by the x squared, the minus 3x, and the 4, and the 3 also was multiplied by the x squared, the minus 3x, and the 4. And now finally, combining like terms, we get x cubed. A minus 3x squared and the plus 3x squared gives you 0x squared. 4x minus 9x for minus 5x, and then just plus 12. X cubed minus 5x plus 12. Okay, now, when we did this, we multiplied the polynomials horizontally. There's actually another way of doing this. We can multiply the polynomials vertically. similar to the way you handled multiplication in arithmetic. Let me show you that. The answer, of course, comes out exactly the same. Okay, we want to multiply x squared minus 3x plus 4 times x plus 3. Okay, I generally put the polynomial with more terms, say, on the top, the one with fewer terms on the bottom. And we do exactly the same thing. We will take the x and multiply it by the x squared, then by the 3x, then by the 4. We're still using the distributive rule, but we're doing it in this vertical fashion. Okay, x times x squared gives you x cubed. X times minus 3x gives you minus 3x squared. X times 4 gives you 4x. The same terms we got over here, x cubed minus 3x squared plus 4x. Then, having distributed the x through the polynomial over there, we will now work on the 3. Plus 3 times x squared gives you plus 3x squared. And when you're writing down the second line here, you do it in such a way that the like terms fall underneath each other. 3 times minus 3x gives you minus 9x. 3 times 4 gives you 12. Okay, this is the vertical way of multiplying the polynomials, and it has the advantage in that the like terms just come right under each other, and you can combine them very easily. And of course you get the same answer, x cubed minus 5x plus 12. Let's try another example. Before we get to that, you might want to look that you got exactly this x cubed minus 3x squared plus 4x appears here. The 3x squared minus 9x plus 12 from over here just appears right underneath it. You want to multiply 2x minus 5 times 3x squared minus 2x plus 1. Okay, I'll do this with the vertical treatment, so I'll write 3x squared minus 2x plus 1, and underneath it 2x minus 5. And then I'll say 2x times 3x squared, that gives us 6x cubed. 2x times minus 2x gives us minus 4x squared. 2x times 1 gives you plus 2x. Then, minus 5 times 3x squared gives you minus 15x squared, which I'll place here. Minus 5 times minus 2x gives you plus 10x. Minus 5 times plus 1 gives you minus 5. Adding up the like terms, we get 6x cubed minus 19x squared plus 12x minus 5. Now, a situation which occurs very often and which you have to be very familiar with is multiplying a binomial by a binomial. That is a two-term polynomial times a two-term polynomial. Okay. In fact, we did one of them earlier. The first problem we worked out today was a two-term polynomial times a two-term polynomial. We had x squared plus 2 times x plus 3. We used the distributive law several times. We had x squared times x plus 3, and then 2 times x plus 3, and then x squared times x, and x squared times 3, 2 times x, and 2 times 3, giving us this final result. Okay, now the idea, of course, is that every term in the first parentheses had to be multiplied by every term in the second parentheses. Okay, if we look at the result over here, there is a useful mnemonic, okay, a handy mnemonic for remembering how to do this. X squared times x. We took the first term in the first parentheses times the first term in the second parentheses. X squared times x. Okay, let's call that f for first. X squared times 3 that we have over here. These were the outer terms in the parentheses. Here are the two parentheses. These are the outside terms, the x squared and the 3. Let's write that with a O for outside. The 2 times the x. These were the inner terms in the parentheses, so let's use an I for inner. And then the 2 and the 3 were the last terms in the parentheses. So L for last, giving us the mnemonic FOIL. First, outer, inner, last. First, outer, inner, last. Okay, just a handy way of remembering how to multiply a binomial by a binomial. It's only good for two-term polynomial times a two-term polynomial. A binomial times a binomial. We couldn't use it on this example that we had over here. This was a two-term polynomial times a three-term polynomial. Okay, then you have to do it the long way. Okay, if you have just two terms times two terms, however, we can use this FOIL method. It's the same thing, just multiplying every term in the first parentheses by every term in the second. Okay, this is a way of just remembering you haven't left anything out. You'll multiply the first times the first, the outer times the outer, the inner times the inner, the last times the last. Let's try some examples. X plus 2 times x plus 5. This is a binomial times a binomial. First, x times x, then the outer, x times 5, then the inner, 2 times x, and the last, 2 times 5. Of course, you won't really be writing down this step. We'd like to get you to the point where you can do this in your head. I just wanted to illustrate it the first time. First times first, outer, inner, last. And of course, you get x squared. You get 5x and 2x. The outer and the inner usually can combine, and we get 5x plus 2x, 7x. 2 times 5 gives us 10. And I said it would be nice if you could do this in your head, and after a little while you will be able to do it. The first times the first gives you x squared. Outer is 5x, inner is 2x. They combine to 7x. Okay, 2 times 5, the last terms give you the 10. X squared plus 7x plus 10. Let's try another one. A plus 7 times a minus 3. First, a times a, that's a squared. Outer, a times minus 3, minus 3a. Inner, 7 times a for 7a. And last, 7 times minus 3 for minus 21, giving us a final answer of a squared plus 4a minus 21. Okay, let's just try one more. Y plus 2 times y minus 6. First gives you y squared. The outer terms give you minus 6y, the y and the minus 6. The inner, plus 2y, and the last, minus 12. Once again, the outer and the inner combine, giving you y squared minus 4y minus 12. Before we end this videotape, I just want to caution you about a particular example. If you see a problem like this, okay, 2x plus 3 squared. That is just a word of caution. 2x plus 3 squared. Okay, this is 2x plus 3 times 2x plus 3. 2x plus 3 taken as a factor twice. Okay, this is to be multiplied, okay, the way you would multiply a binomial times a binomial. You can write this as first, outer, inner, last. 2x times 2x gives you 4x squared. The outer terms give you plus 6x. The inner terms plus 6x. The last terms plus 9 for 4x squared plus 12x plus 9. Okay, the problem here is that sometimes people get sloppy and they say 2x plus 3 squared. Well, I'll square the first and I'll square the last. Okay. You don't do it this way. This is not equal to this. You multiply it. It's a binomial times a binomial. You can do it first, outer, inner, last. Okay, don't get careless and say, well, I'll just square the first and I'll square the last. It doesn't work that way. It is 4x squared plus 12x plus 9, not just 4x squared plus 9. And that brings us to the end of this tape.